Nuclear power plants work the same way that a lot of power plants out there work. A fuel source is used to generate heat, which heats up water to create steam, which turns a turbine. The turbine contains a magnet which spins, which pushes electrons through a conductor and generates the electricity. Now, in the case of a nuclear reactor, the fuel source is a radioactive element, and this, in the case of Japan, uranium-235. Now, nuclear fuel is incredibly efficient. It's incredibly powerful in terms of the output energy available. A tiny pellet of uranium-235, the size of the end of your pinky, can actually produce the heat equivalent to more than 800 kilograms of coal. In order to split uranium-235, you need a bullet, and in this case, it's a neutron. A neutron strikes the atom, causing it to break apart into two lighter elements, as well as producing 3 more neutrons. Now, all of these particles have a tremendous amount of kinetic energy, which in turn can heat the water, and the 3 neutrons are also available to collide with more of the uranium-235 and cause them to split. So if you think about it in terms of bowling, if you have a bowling ball coming in and it hits with the first atom, that can then create a cascade effect or a chain reaction. Nuclear engineers have come up with ways to control these chain reactions so we can tap into the incredible amounts of energy that's available. Now, one way they do this is with control rods made up of special material that will actually absorb neutrons. So imagine your nuclear reactor core and you've got your fuel rods, which might look something like this, and they contain pellets of that uranium fuel. Now, in and among these fuel rods, you'll have those control rods which can be deployed to absorb those neutrons and to stop them dead in their tracks before they cause more atoms to split. If we go to our bowling pin model here, you can imagine if we place control rods in among the reactor core now. We'll just add one more. You can imagine that that incoming neutron is not going to have the same chain reaction effect. In this case, you've got a controlled reaction. So in a nuclear reactor, those control rods can be raised or lowered to control the rates of nuclear fission or the numbers of atoms that are splitting, and that controls the rate that heat is produced.